Now with const, it's a different thing. I'll get rid of my let code here, and I'll create a constant age 27. What do you think will happen if I now hit run? It's still 27. So that's not too surprising. But what happens if I now set age to be 29? What do you think we'll see in the console if I now hit run? Well, we'll get an error that we're trying to assign to a constant variable. So this really is no variable in this case, it's a constant. It may not be changed. Therefore, it's common to write it all uppercase to clearly show that this is a constant. And if we ever try to change it, we will get an error because that is not possible. A constant is defined once and then it should keep its value. Now, what do you think will happen if I create an array, ages here for example, with 27, 29 and 31? And of course I can print ages here. If I hit run, well, we see the array. Now, what do you think happens if I push a new value onto that array and then print it again, like this? What do you think we'll see in the console? Will we get an error? Well, we see the original array, and then we print a new array with 25 added to it. Now that's certainly strange. Didn't I say that a constant may not be changed later on? But it seems like we did change it, right? Not really. Remember that arrays as well as objects are reference types. This means, what does this constant actually hold? It doesn't hold those values. It does hold a pointer to those values, a pointer to this array. The array is placed somewhere in memory, and the variable or constant here only holds a pointer to that space in memory. Therefore, we don't change the constant, we're not changing the pointer, we're not pointing to a new object. We're only changing the values to which the pointer points. But that is totally valid. We're not hurting our constant here because, again, the constant value, the pointer, isn't changed, only the value in the background. That's why we are able to manipulate this array, and for the same reason, we would also be able to change an object. Like, let's say we have our constant object, which might look like this. And here we have our age set to 27. Now, of course, I print object here, and thereafter, I'll also print it down here. Thereafter, I'll go to my object and change the age to be 30. If I now hit run, we also see that the object was changed for the very same reason as the array. It's a reference type. The pointer isn't changed, only the value. I'm really stressing this because this is important to understand how constants work here and why you are able to change the constant, or to be precise, to change the value of that constant if you're using with reference types, because you're not really changing the value, only the value to which the pointer is pointing.